Hello again, everybody. Hopefully, you learned a lot from step 1, installing Code Blocks IDE. We're going to go on and move on to step 2, learning about variables and how to use them and then initialize them. As you can see, we started here at timmymx.com. You'll be able to go there. You'll see the link in the description. You can go there and get some extra support for my tutorials. If you have any questions, you can post a comment and I answer them. And you can go through here and see some of the stuff we went over and get a recap and see the source code. So we'll begin now. So I'm going to bring up my code blocks. There we are. After you've brought up your code blocks, you'll notice that right here under recent projects you're going to have your cpp training.cbp if you worked with me on the last video of the series. So we'll click that. You're immediately going to be brought up to the source code. You should. And if not, then you just remember you bring down sources, double click main.cpp, and you got your source code up. Now, looking at this program, if you think about it, we really didn't do much with the hello world. We were able to put a little bit of text on the screen. Now, where programs come into being useful is the fact that they can work on data. We can put something in, program an algorithm to make it come out a certain way, and then we can, as humans, can use the output, be it a video game where a user clicks the screen and attacks a minion and kills it and gets gold. Well, the input would be the click, the output would be what the player is seeing. Now, as for spreadsheets, you put something into a block, and that's like a variable right there, a block. It contains a value. Then you operate on it a certain way, and you get an output, which is the spreadsheet's output. So today we're going to learn how to store things into variables and learn about them. Well, starting off, we've already got our program from last time, the Hello World. We're going to end up modifying this quite considerably. But let's start off by thinking about what a variable is. A variable is a storage box. You assign a value to it, it stores the value, and we can mess with it. It's just like algebra you learned in high school. So if you look at the code right here where I'm at, you put a equals 3. We know that a equals 3. So now a is 3. But in programming, we have to initialize. We have to create these variables so the compiler knows what type of value it's looking for, because there's many different values in the world. There's strings, there's strings of characters, so that you have like a sentence. There's numbers. There's many different types of numbers, everything from simple whole numbers to decimal numbers, numbers with a decimal point. Then you can have a whole other slew of things. So we need to tell it what we want. Well, 3 is an integer, and I don't expect to be using anything other than integers. So to declare an integer, you simply put int. And when we want to declare it, we can simply put this right here, int a. Now that tells the compiler a is a variable which is now going to contain an integer. Now calling it an int in a 32-bit operating system, you're going to have a 4-byte group of memory being used. And you can store a value anywhere from somewhere around 2 billion plus or minus. So you can have a negative 2 billion or a positive 2 billion. So now that we have a variable, we want to make it equal something. So we said we wanted to make it equal 3. So a equals 3. So now we know exactly what a equals. So let's create another variable, int b. And let's make b equal 5. Now remember, just a recap, always put these semicolons at the end of things, at the end of each line, because that'll tell the compiler to end that line. It needs to go into the next statement. Now that we have have two values, we could add these together or subtract them, multiply, divide. So let's create us another one called variable called sum. Now you can name your variables about anything. We'll go over the naming real quick. You could name a variable sum of all numbers, or just simply sum, whatever you want, and it stores the value. So now that we have A and B that we want to add together, it's a good practice to go ahead and zero out your values if you're not going to assign something to it directly. But since we're going to go ahead and assign something, A plus B, so now we know that sum equals 8. Well, now that we've got variables being able to store, we've stored variables, we've been able to make them equal something, and then we store that, what they equated to, into another variable. Well, that's great, but what use is that? We can store a bunch of different numbers and move them around in memory, but we aren't really doing anything with them. So let's say we want to put this on the screen. Well, we already know how to use cout or console out from the IO stream standard library. You simply need to do this. We could go delete, let's delete hello Tim and put sum with a semicolon. Put a space after it just to make it look pretty. And then after these brackets, let's get rid of indel real quick. After these brackets, we simply have to put sum. So now it's going to go in here, print the literal string that we put, sum, and then whenever it goes to the next parameter, it's going to say, let's print out sum. So that's going to be A plus B. So it's going to end up printing 8 on the screen. So I'm going to go ahead and build this. Remember how to build? You go up to build, and then click build. Down here we notice that we have 0 errors and 0 warnings. Let's go up and run it now. Now we notice that it says right here, sum 8. It's pretty good. So now we're actually operating with variables and getting them to store values and then operating on those values and then taking the output. But let's go a little bit further. Maybe we want to display what we're doing, the sum of those. So we want an equation to be displayed up here. So let's get rid of this again. So cout. Maybe we want to show that it's 8, 3 plus 5 equals 8. So we could simply put A, then our literal string, plus, put the spaces around it just to make it look better, B equals sum. Now, this looks really complex because of all the extra left carets, but it's really simple. First thing it's going to do is put the value of A up on the screen, which is a 3. Then it's going to put this literal string up there, which is the plus sign. It's going to put a plus with 2 spaces around it. Then we're going to put the B up there, which is 5. So it's going to be 3 plus 5. Then we're going to do the literal of equals sum. Let's build it and try it out. Again, we built it. Let's run it. 3 plus 5 equals 8. So you can quickly start to see how variables will start. I mean, that's the core of programming. You need to be able to take and store data and then store the output so that you can use it. Let's talk about a couple of the types of variables. We'll go over the fundamental data types. Now the fundamental data types are basic ingrained data types that C++ knows. So, a few of them would be something like, we know int, which is an integer, float, which is a floating point number, which means it has a decimal point in it, where you can have, floating point numbers. So Each a floating point and a double, which we'll go over that. There's a double. Those are both floating point type numbers, but the difference is float is called single precision, and double is considered double precision. Now, then why wouldn't I'm sure a couple of you are wondering why wouldn't you just go ahead and use double every time instead of using a float? Well, you have to remember that each data type takes up so much memory in your RAM, your random access memory. A float takes up 4 bytes, while a double takes up double the memory because it's double precision, which is 8 bytes. And the difference comes into play with how big of a number it stores and how many decimal places it can go. A single precision can store up to about 7 digits. A double can store up to about 15 digits. Then we have a few other data types. Bool, or Boolean. It's either a true or a false. That's all it can contain. It can either be equals true or equals false. That's useful for flags, like what we call flags, where you have something happen, and if something has happened in your application or program, and you want the program to remember that said thing happened. Like say a player initializes their character. Well, this character is now initialized. Well, you wouldn't want to reinitialize the character every time the person logs on to the game. So you would make a flag called is initialized and make it true once they've initialized that character. And that's the kind of thing that you use booleans for a lot is to make sure that things are true or false. And you'll go into that a lot more whenever we get to logic, which we'll go over in either the next or the following video. Now there's another data type called char, which is meant to be a character or a small integer. It's only 1 byte in size, which makes it very small. So you'll see a lot of times for like simple counters where someone's going to count through a certain iteration only 5 or 10 times, they'll use a char because it's so much smaller than an integer, which it's half the size of a short integer or 1/4 the size of a regular integer. That char can store anywhere between -128 and 127. So 256 different values. 0 through 255 if it's unsigned. So we could sit here and store 34 in it. So that gives you like the basic types right there of your built-in C++ fundamental data types. Using these you can do a lot, but you still need to be able to use custom, custom data types. You'll want to be able to do more. And now the thing is, you can later on you'll learn to extend these and make them into what you want, or groupings of these things to do different groupings of variables to create objects. But that's way later on. So now that we've declared, let's get rid of these since we only want to really have these declared right now. Now these are your declaration statements, as we said, right here, here, here. You declare the variable. So when you declare a variable, it takes a little bit of memory from inside the system and saves it for storing a value. Well, whenever you initialize a variable, that's where you make it have its first value. Now, here's a little trick. Say you know that a is going to equal 3. Right from the beginning, you want to have it already assigned. You can actually do this. Int a equals 3. Then that negates needing this line. So it makes your code smaller. We can do it for b. b equals 5. You can even do it for sum since we already know what a and b are going to be. So it's a plus b. Now just always remember that when you do this, it always is going to store, the equal sign is your storage. operator, it's always going to store to the left. So A equals 3. So if you were to say A equals B, it means that A is equal to B. So actually, A would be 5 instead of B being 3. Well, now that we have that, that works pretty well. We'll go into setting up a string. We want to be able to store sentences and stuff so that you can create better outputs for your user. Well, first off, as we spoke before, when we include something up here with our preprocessor directive include, that's to allow us to use functions from a library. Well, IOStream does not contain strings, so we need to include another one. Here's another basic library, string. So now we can declare types of string. String username. So let's create a username. We can even declare it like this, like where we were going to go ahead and do assign the value to it. You put something in parentheses to store it into the string. So maybe we'll put my name, Tim. So now username, the variable, is equal to the string Tim. So let's create our hello world little statement again, except let's say hello to us. So cout for console out, a literal hello, a space just to make it look good. Let's use the variable username, and let's end it with an exclamation mark. And we need to put an endl at the end because think about it, if we don't, then our next cout statement is going to start printing onto the end of this statement, and it'll just look like a mess. So we put an endl to end the line, send a carriage return, and you'll see it. So now that we got this, let's see what happens. Let's build it and run it. Hello, Tim. And we still got our other values being computed down there. But everything runs right. Now, here comes another thing. What if we want to make sure that we remember something? What if when we stored this string Tim, why did we do it? Why did we store it? Later on, whenever you create bigger and bigger projects, you're going to have hundreds of lines, and you're maybe write it over a couple days, what you're writing. Well, you're not going to remember exactly why you do some things, or maybe the inputs and outputs that you expect. So you'll want to be able to make a comment. So what C++ has something for us. The double / creates a comment. So now I could put stores Tim into variable username. So that just tells me what it does. Now, and here's the cool thing about comments. The compiler doesn't care. It skips them. It doesn't even look at them to see if it needs to use them. It just acts like they're not there. So that comes in handy. Like if we didn't want this line to be in our code anymore, we simply put a // in front of it. Now if we go up and build it, we get a warning, but don't worry about that. Then we run it. Notice that equation's not there anymore. But we can uncomment that code, build it, and it's back. And that's all because of comments. And another thing that you can do is called the block comment. So we'll go up to the top and create a block comment. Now this is something that every programmer should do, is create a top part, your title, to your program. So maybe we'll call this program name hello variables by MEMX. You could put a date in here if you want. I'm going to put today's date. We can put that, and now that'll be stored with the source code file, so you get attribution to your source code. So if you ever give it out, then people know who made it. So we can build it, and you'll notice that none of that comes up. It doesn't even notice it. As long as it's within the /* and then */ anything between these two is considered a comment. So you could technically comment out your entire program by simply putting star slash or slash star star slash around the whole program. So there we go. That's probably enough for today. You've been able to learn how to initialize variables, the different variable types. You have been able to display that in a structured cout or console out structure. You've been able to use a string, learn how to include strings into your program, use them and output them. And I think that with this, you'll be able to create some interesting little programs. I mean, take it and try to move around some variables. Maybe make something that you can input a few different numbers into, and it'll come out with an answer. And try different variable types, see how they work out. We'll go over more in depth some uses of all this in our next video. And check out www.timmymx.com, and you'll be able to see the actual any add-on stuff and a recap on all this. So thanks for watching, and take it easy.